Thanks everybody for joining us today. My name is Megan Dettenmeyer. I'm the Utah State University Forestry Extension educator, not professor. I'm sitting next to Darren McAvoy. He's the Extension Assistant Professor of Forestry at Utah State University. I'm going to introduce our panelists today, and then I'm just going to do a couple housekeeping announcements, and then we'll go ahead and get started. So if you're here for a webinar on cross-laminated timber, what's all the fuss, you're in the right place. Like I introduced Darren, he's the Extension Assistant Professor of Forestry at Utah State University. He's going to start off our hour with a snapshot of the ecological impacts and drivers that have led Utah State University to explore the niche market for cross-laminated timber. Next, we'll have Jerry Goodspeed give a couple of minutes talk about his projects at the Kaysville Botanical Center. He's going to discuss how the future cross-laminated timber building will help the Botanical Center fulfill their mission as Utah's Extension University. And our third speaker will be Steve Shrader. He's the Business Development Manager with Euclid Timber Frames based out of Heber, Utah. He's going to offer his perspective on the market for this product, as well as discuss some of the hurdles he's had to overcome as Euclid has become a leader in cross-laminated timber production. And finally, Method Studios is going to present their information. Van Lewis is here to talk about his perspective on what it's been like to work with cross-laminated timber from a design standpoint. So I'm happy to have all of our speakers here today. I'd like to draw your attention to our upcoming conference we're going to be having here on the campus in Logan, Utah, Restoring the West, Climate Disturbance and Restoration in the Intermountain West. We'd love to have as many people as possible join us in Logan for this conference. And our next webinar will be November 30th, Soil Compaction and Urban Trees. Dr. Brian Scherenbrock from the University of Wisconsin-Stevens Point will be here to talk about this important topic. I'd also like to draw your attention to an upcoming conference. If you're joining us today for this cross-laminated timber conference, this Mass Timber Conference is probably really of interest to you. It'll be happening March 28th through the 30th in 2017 in Portland, Oregon. So please mark your calendars for this conference. And the deadline is coming up for exhibitor spaces and things of that nature. So please mark your calendar for that. And without further ado, I'm going to hand it over to Darren. Let me get this out of the way for you, Darren. And all right.
Thank you, Megan. Appreciate it. And thank you, everybody, for attending. Appreciate your participation in today's event. I'm Darren McAvoy, Extension Assistant Professor at Utah State University. I'm the chair of the Utah Biomass Resources Group, and these are our partners, and we get a lot of our funding from the Forest Service and from the BLM, and you can see our other partners. For this project in particular, we're hooking up with Euclid and Method, and the USU Botanical Center, who are also presenting at this event today. We'll all be talking and referring to CLT today. That's cross-laminated timber, or ICLT, that's interlocking cross-laminated timber. Well, that's what this is about, so we'll be talking about those topics further. In 2015, the Utah UBRG, or Utah Biomass Resources Group, received a Wood Innovations Grant from the USDA Forest Service for about $164,000 for the design of this building that you see the mock-up of here. It's going to be the first public cross-laminated timber building in Utah, and it will be at the USU Botanical Center in Kaysville, just off I-15, north of Salt Lake City. Private funds are being raised to build the structure, and it's going to be the centerpiece of the already existing USU Botanical Center. It's going to be an extension teaching facility. It's aimed at teaching, in particular, underserved youth in the community. And Jerry's going to talk a lot more about what's in the building, and your other speakers are going to talk about the construction. I'm going to talk about the forestry and the sustainability of buildings and how we approach buildings, and a little talk about ICLT buildings and our awareness building program. For the UBRG, waste wood utilization is our target. start with the problems at ICLT that we hope to address with CLT and ICLT. And that starts with fire and bugs and sustainability. This photo is the result of a spruce beetle attack up on Wolf Creek Pass, just outside of Heber City, a couple of years ago. And and spruce beetle has been moving through Utah for my whole 20 years here. And here's a bit of a shocker. In this day of conservation, we actually want to use more wood, not less wood. I'm going to tell you why. This is not a picture of your tailpipe, although it is a picture of carbon dioxide being emitted into the atmosphere, just like your tailpipe does. This is a picture of Douglas fir beetle up on Indian Pass outside of Price. And these trees are slated to stand and dead and tip over and rot and emit that carbon into the atmosphere. And we think we have a way that we can utilize this instead and sequester that carbon. Presently, we waste tremendous amounts of this resource. Beetle-killed wood typically can't be sawn into boards. It tends to crack and check for traditional high-value lumber. But we can make house logs out of it, but there's a very limited amount of house log market available. We can make lower value boards out of it that we can use for cross-laminated timber. Some would call this a restoration byproduct, and others refer to this as doing restoration by the product. And we can use the product to help pay for the restoration. That's the bottom line here. I'll give you a feel of the scale of the bark beetle problem and how big the problem is and how small the bark beetle is. This photo or this map was from National Geographic. And if you travel around Utah and Colorado, you see the scale of the problem. It's tremendous. But then you look at this map and look up into British Columbia and in the Northwest, and you see that our problems are small in comparison. And so pretty important that we realize just how much, and this is just mountain pine beetle, does not include spruce beetle or Doug fir beetle or any of the other waste wood problems that we have out there. And of course, we're concerned about this turning into a wildland fire hazard, and more danger to firefighters and people living in that environment. And again, pumping more carbon into the atmosphere that could be sequestered. It needs to be said that in any forestry operation, we waste a mountain of wood. That's just the way it is. Only 30% of it tends to make it to the sawmill as saw logs, and the rest of it we tend to pile and burn or leave scattered out in the forest. And we think there's better ways of doing this sort of business. And the way we build buildings in our society, we use concrete and steel, and we can build these beautiful structures like this here on the USU campus, but we can build just as beautiful and just as durable and arguably even more durable buildings with cross-laminated timber. We see this as a way to decrease our dependence on concrete and steel and use more sustainable methods. In the 20 years I've been at USU, every 2 or 3 years another building comes down, and that's just the way business is done in large institutions, I gather. And this was the agriculture building. I assumed it would be there forever, but it was only designed to last perhaps 50 years. In many cases, CLT buildings are designed to last twice that or more. Now, this is a picture of sustainability. This is a picture of a stone building on the island of Corsica in the Mediterranean. I got to visit there last summer. I like to include it. It's 6,000 years old. That's older than the pyramids in Giza. And so it's a very sustainable structure, but perhaps not that pleasant to live in. This structure, on the other hand, is an ICLT structure made by Euclid Timber Frames. It's a Girl Scout camp structure, and it's got beautiful light and it's a warm, inviting feeling. Notice the blue stain on the walls. That's from the fungus that travels on the beetles' backs and gets into the wood and affects the value of the wood sometimes. Sometimes for the worse, sometimes for the better. In this case, we think it adds a lot of aesthetic appeal to the building. And just wanted to point out, we have a little, this is our Utah Forest News, our newsletter Megan and I work on together. It's one of our means for spreading the word about cross-laminated timber. webcasts like this and giving presentations around the country, like I've been doing in the last few months and will continue to do, is our sort of overall method for getting the word out about cross-laminated timber. We sure appreciate you guys listening in today. That's all I have.
Thanks, Darren.
Okay. So as Darren mentioned, I'm Jerry Goodspeed. I direct the Utah State University Botanical Center here in Kaysville. And we need to figure out why this is starting at the bottom and not the top. All right. Our goal at the Botanical Center, basically, guide the conservation of our natural resources is basically what we try to do. And we do that in a number of different ways. And so the ICLT product fit well within our goal, or within what we were trying to accomplish. And we needed a building, and I'll explain a little bit about what we're trying to get done with that building as well. A little background on the Botanical Center. We are approximately 100 acres, a little bit more than that. And it's a very unique situation where we're abutted by about a 50-acre research farm for the university. The Ag Experiment Station abuts our property. And then we have 100 acres of public ground that we're trying to develop into a center for education in different areas, especially regarding our natural resources. The other thing that we have that's unique on our property is we also have the continuing education site. Currently, we have 500 off-campus students enrolled in different master's and bachelor's programs on our site as well. So it's a very unique situation that we have. On site, we have wetlands, some ponds, about 8 acres of ponds. We have mini gardens, and I won't go into everything we have, but an arboretum, and thousands of visitors each year as well. And we're a new garden, rather we're a new center, I should say. I like to call it an education or extension center rather than a garden. And we are growing. We're only about 10 years old, and so we're still in the process of establishing what we want and getting bigger as well. The other unique situation that we have is within about 35 miles of our Botanical Center, we have 1.7 million people. So we're in a very urban area where we can make a lot of impact on people, and we see a lot more potential for people coming to our property in the future as well. So what we were looking for is a building that would allow us to do different things in the building itself, the things that we need to have on site. Obviously, you'd have the ICLT promotion where we could show people this product and how it's using some of our natural resources that we're otherwise wasting, and helping with a lot of different parts of our environment. The other thing that we like is it is programmed to sit in the middle of a orchard, vegetable garden, berry area. So we have about an acre and a half that we have dedicated and already developed into a demonstration area where we can show people everything from how to grow, grapes, tomatoes, berries, peaches. We have 50 different varieties of apples to show them, the different varieties that you might want. And it's also targeted at using water wisely. So we monitor everything that goes on and off the property as well, or into this property specifically. And so we wanted to present a holistic food education idea where it's not just a garden to learn how to grow things, but we needed a building that would allow us to show them how to grow it, how to harvest it, how to cook with it, how to preserve it. And we have a lot of young families. We have a lot of low-income people where Extension is working with them, trying to teach them how to grow their own produce. And a lot of our millennials or younger people want this very much. And so we needed a building that would have a kitchen, not just a kitchen, but an area where they could come, not just watch, but they could participate. So it would be big enough where they could have hot plates on the tables and they could actually do what they're seeing done and participate, so that it's an experience, what we like to call an experience. And once you have that experience, and you can go home and you can recreate that much easier than watching it on a YouTube video. We also needed a building where we could do our horticulture education, everything from beekeeping to our pruning demonstrations. We do a number of things here. community outreach. We wanted to reach out to our community, which is Kaysville and the Davis County area, and give them a facility that they could then come and have different programs in it as well. Youth activities, 4-H activities, obviously. As I said, we're working with Kaysville City. The government of Kaysville is very much involved and would like us to have a facility where they can hold some of their meetings. And we'd like to be able to broadcast and receive information from this building as well, so that you could have something like this web seminar in the building, and by so doing, then you could actually see the building and talk about the building, and we could promote it a little bit. So those are some of the reasons why. And now we need to fund the building. We had about an $80,000, $100,000 grant for the garden itself, the demonstration garden, and then we've got a Forest Service grant to do the planning, to do all the design work, and that's what we're working through right now. And so now we're at the stage of let's take it a step further and let's get the money together for the building itself. And we're doing that through other different grants, fundraisers. We have a lot of fundraisers on our site. We're working with donors. We're having naming rights and other things so that we can afford, so that we can actually build the building itself. And this will fit into our master plan with the Botanical Center, where we see the building will sit next to the amphitheater, where it can also host events, pre-events, post-events. It can also be a main 4-H and youth center. And our master plan is that we have different pods around our facilities here, our center. And the reason that we're doing that is so that we could have the youth pod out on the northwest corner, where the youth could be having an activity. We could be doing the cooking activity up by the ICLT building, maybe an arboretum demonstration in the arboretum. Then we have a large field just for big activities. That's just kind of the general overview of where the building is going to go and what part we see it playing at the Botanical Center here. And that's all I have, Steve, if you want to take it from there.
Okay.
Hey, Jerry, you got to stop. Jerry, stop. There you go.
Okay. I was getting there.
Okay.
So what do I do?
So all you do is share your screen.
There we go.
You got it.
Am I up and running? Okay, so are you seeing the
Got it.
Okay, good. So I'm Steve Shrader with Euclid Timber Frames, and I wanted to first put a shout out to Megan, Jerry, and Darren for allowing this to happen and going forward with this. We've been having a good time, an educational time going through this process, and I just wanted to let people understand a little bit more about Euclid Timber Frames. I kind of have a couple different hats on. Megan introduced me as business development with Euclid Timber Frame, but we also have an association with a German CNC saw company, and I think the two hats have really kind of helped develop, not us specifically, but those disciplines have helped CLT, particularly the ICLT product develop. This would be Euclid Timber Frames up in Heber. I like to tell people that there's a rainbow every day where we work. We love where we work. We love our offices. This is what it looked like a couple days ago. We had a little bit of a snowstorm up there, and we'll be seeing more of that. This is the inside of our facility. This is what timber framing is. I don't know if some of you can see the pictures there. Some of the joints where the columns and the beams come together, it's actually oak dowels that are holding the joinery together like furniture, mortise and tin and dovetail type of stuff. There is some steel in there. On larger spans, we can't get away without it. Unfortunately, some of the engineers won't allow us to. Euclid's been around for quite a few years. 1987, we were actually out with our Carhartts and Japanese chisels and Japanese saws, hand-hewing timbers to make them look like they were actually cut by hand on site. And in the last few years, we've actually been doing that, cutting and harvesting trees on site and incorporating them into ICLT panels that are going into homes. One of the questions we were talking about a little bit earlier, I kind of like to go through why the name Euclid. We've been asked several times. It seems like everywhere we go, what does that have to do with anything? It was kind of interesting when we were first involved with timber framing. We didn't know exactly what we were going to call ourselves. We were reading some books on timber framing and going through a lot of European construction manuals and things, looking at how things were done over there. And we came across a lot of them referred to Euclid, a Greek mathematician, College of Alexandria, way back in the day. One of his contemporaries was Pythagorean, and we all know Pythagorean theorem, and in timber framers, we really couldn't get away without using that theorem, and the name just kind of stuck. Because of what Euclid did, and at that time frame, construction rafters and trusses and bents were being built uniformly. They could calculate and measure timbers and spread trusses throughout a building and do it uniformly. These are some pictures of some buildings. I don't know. That's me eating an eclair in Colmar. Sorry about that. I don't know how that got in there. But there's a lot of half-timbered structures. This is a little town in Miltonburg. I've stayed in this hotel about the time Euclid and this math really started catching on. This half-timbered timber frames started becoming very popular. Some of you may understand what jetties are and how they actually would tax buildings in the day on the square footage of that base floor, the property taxes. And so builders, entrepreneurs that they are, came up with ways to increase as they went up, increase the square footage of a floor. And you know, the mathematics and what was involved in that was basically produced because of the Pythagorean theorem and the geometry, the school of Athens from Euclid. And that kind of gives you a little bit of an understanding of where Euclid came from, but it also introduced where timber framing went forward and where it is today, and where Euclid picked up with it with another company that I'm going to describe now. So CAD, obviously everyone knows, is computer-aided drafting. CAM is computer-aided machinery manufacturing, and CNC is the computer numeric control of a lot of servo drive type machines that translate drawings straight into an actual part. These are two pictures of two roof systems. The one on the left is what you'd see in Europe. Just last month when I was out there, you could walk into a lot of barns on the countryside and see a truss system or a timbered system that looked a lot like this. But today, on the right-hand side, there's a lot of software and machinery that is allowing very creative, very interesting, longer spans, more unique type of construction, but yet still the base product is timbers and woods. Computer-aided design software and this computer numeric control machines. This was all, this is the type of structures that you're seeing. This was our first Hundager machine. This introduced us to a company out of Europe, Bavaria, southern Germany, called Hundager. Hundager has been around since about the early 80s, and they started with a basic timber type handling systems into creating joinery machines that would do the dovetails, those mortise and tenons that we looked at earlier that were being done for many, many years are now being produced without any layout whatsoever. You can design a product right there in the software, and it'll go straight to the machine. Hundager's grown quite a bit since we've gotten to know them. This is their facility there in Havagen. There's 330 employees, and there's now 4,700 machines worldwide in our country. I hope that's not too loud, but I just wanted to show a little demonstration video of what the latest Hundager machine is. It's the robot arm. It's about a 7-axis machine that can change out every kind of cutter imaginable. I think it'll hold up to 16 different cutters in there. This is an actual dovetail cutter. It's going to be putting in a dovetail tenon on a compound rafter. Now I wanted you participants and everyone to understand how developed some of this this machinery and CNC equipment is. Again, realize that this was all designed in a design software program that's also made in Europe. And this part, as complex as it is, will be cut in less time than it would take to lay out each one of these joints and cuts with a pencil and a tape measure. And you don't even have to measure or cut any, or measure and lay out anymore. So I'll cut it there, but this is a screenshot of a timber structure that one of our guys is working on up at the shop. There's different softwares available. Again, all of them are out of Europe. There's CADWork and HSP CAD, Dietrich, and all of them interface with the AutoCAD or Autodesk and Revit type project softwares that are out there now, and we can take those models and incorporate them from BIM to FIM, which is fabrication information models. This is in the upper skeleton. There is a drawing of a beam with some specialized joints that are being designed on the CAD system, and then once that translates, well, it's automatically translated. It goes right into our Hundager software, and you can see everything is everything exact dimensions, and the whole 3D model is transferred into the Hundager software. We can actually use the Hundager software to run through simulations, make sure we're getting the best results, reduce as much waste, reduce as much handling. One of the significant features of this software is it'll tell us exactly to the second how long it will take to cut that part. So again, we've removed all the layout, all of the pencil marks, the tape measure marks, the squaring up. It's all done by the machine, and it will also tell us exactly to the minute how long it will take to cut each one of the members for estimating, for scheduling, and for helping us be more competitive and more sustainable in our industry and trade. So we're seeing, because of what I started off talking about with Euclid and that math, you know, the algorithms in these softwares and the saws are allowing us to build much better looking buildings more affordably, reducing a lot of waste. Of course, using wood, sustainable material. We can become more creative with the shapes and the designs that we're using. And we're seeing a lot of competitive opportunities to reduce cost overruns, and helps us communicate with the rest of the team, with the rest of BIM information that is being produced. So this is a drawing that actually was very creative and surprising to me. The CADWork software company shared this with me, and it actually was an actual building that was built, and it was all out of wood, all out of timbers, and it all came to represent the model exactly. It's an impressive structure based on the design that was done. So that takes us into mass timber, ICLT and CLT. There's a recent article about a building that was done in England recently. They have talked a lot about how, in the bold there, the architect designs using 3D AutoCAD software, and program generates material specs and sends it off to robotic or wood routers. This is what they're saying why CLT started catching on in Europe about a decade and a half ago. And Hundager was a specific part of that. And so I hope you can start to see how timber framing and the Hundager starts to bring CLT construction and fabrication into the mainstay, and the technology that's supporting the growth over in Europe and really starting to kick off here in the States. I first saw a CLT home by Mr. Hundager himself. I was invited to his home. This is the base of the Alps in southern Bavaria. And I was almost laughing when I first walked through this home. And I thought, who in the world would build a house out of so much wood? And the more I walked through this home, and the more I started understanding what Hundager was trying to develop, and seeing the technology that was being employed, I was becoming more and more converted, and this was probably in 2003. These walls are actually designed and engineered. There's a product, well, there's a name for a product we have here in the States called EWP, which is engineered wood product. And basically that's just taking wood product that probably has little to no value, as Darren was talking about earlier, and applying cross laminations or specific glues or mechanical features that will engineer this wood to make it very useful and helpful in the construction and building industry. This is engineered so it's cross-laminated, and you can see the little gaps that are grooves are put into each layer of wood, which actually helps in their thermal mass and calculating how fast it takes for high temperatures or low temperatures to transfer through or not transfer through, as the case may be. So CLT, cross-laminated timbers, kind of started off in Europe with dowel lambs and nail lambs. Glue wasn't really a factor for them over there until most recently. This is the house of Mr. Hundager. He used aluminum nails. The panel that I just showed you, this was the finished product, and it's a very predominant building material over in Europe. The UK, Canada has been taking off, and we've been seeing it really grow here in the US. Part of the businesses that Hundager has developed into, one of their companies is this massive Holzmauer, a massive wall or solid wood wall, CLT again, EWP. There is no glue in this; it's all aluminum nails. And I have a little video here, kind of showing the start to end process. I noticed there's some questions, Megan. Do we want to stopping and answering some of those questions, or do we want to keep going and
I think what you're seeing is just some chat, so I'm not seeing any questions yet. So go ahead. Yeah. Okay.
So this is a video. Is that music too loud?
No, it's fine on my end.
So this is the groover machine that takes the raw panels, and this would be what would consider number 2, number 3 wood, really kind of a waste wood that's not being used by other mills. They put those grooves in it that we showed earlier, and this is the nailing machine that does the cross-laminating, and it kind of speaks for itself. I probably shouldn't have to talk here. That's a nailer that, again, is putting a bunch of aluminum nails in each board as it stacks it and evens it out, presses it up against the board before it, so it gets a uniform pallet or billet of CLT. This is the CLT being transferred into the PBA machine that Hundager built. It's a gantry machine. The CLT is put on a table, lasered and squared up, and the gantry actually travels while the panel sits still. The GoPro makes it look like the panel may be moving, but it's actually the gantry and the saw. There's a 5-axis circular saw, 5-axis chainsaw, and other milling tools. This is an example of how you would attach or build a wall plate attachment, showing the groove there of how the CLT would mount to the plate.
Hey, Steve.
This is the 5-axis chainsaw. You can see in the foreground there the 5-axis mill that will cut and router. That's cutting openings, windows, doors, and that type of, all again without any layout, without any tape measure or pencils. All of this is straight from the CAD program to the machine.
Hey, Steve, there's 2 questions in the Q&A, but I have a question. Is that one, that's not at your shop, is it? That's in Germany?
I'm sorry.
Oh. Is that it?
I'm sorry, go ahead.
That's not at your shop, that's in Germany, right?
That's there's a couple shops here in the U.S. That one particular one is with D.R. Johnson on the Pacific Coast in Oregon.
Okay. Shane Stickney asked, do you mill the boards before you make the product? Mill the boards yourself?
Yes.
Okay. And then Elaine, she's just looking for a little more clarification on what exactly cross-laminated timber is. So it looks like maybe there's still a little confusion on that.
Okay, so the cross-laminated timber, again, is wood that most would consider waste. And like Jerry was talking about earlier, or Darren was talking about how the beetle kill or wood that would be what they call first cuts, stuff that are sitting in a lot of lumber yards without really a designated place. But when it's almost like a big piece of plywood. When you laminate those small, weak veneers together, it becomes a very strong piece of sheathing or shear material. Does that make sense? Like OSB or plywood?
Yep. And then Nelson had a question, and then we probably should hand it over to Method so we can see the design of the building. But is Euclid using mostly beetle-killed spruce for their CLT?
Yeah, I'll finish up with this. I think that some of these questions will be answered here in the next few slides.
Awesome.
So again, that was the video. I'll go back through that. Darren brought up some interesting things about steel construction and what was being done on campus. And this article that was recently published, I typed in bold there. I don't like to necessarily read straight from these PowerPoints, but I thought it was very interesting that science and building industry is out there recognizing that a ton of bricks requires 4 times the amount of energy to produce a ton of sawn wood. The concrete requires 5 times as much, and steel would require 24 times, and aluminum 126 times the amount of energy to produce the same amount that it would of a tonnage of sawn softwood. And this is really interesting on how wood performs. The insulative property of wood is more than concrete and 350 times more so than steel. So we came back from Europe. We spent a lot of time over in Europe discussing saws, obviously timber frame. We have a passion for that over there. And then Hundager and others were introducing us to CLT. This is actually a drawing of the new Hundager sales offices. From the top, you can't really see it from here, but from the top, it's actually supposed to look like a saw blade. And they stack the panels up there. These are all CLT, about 13 inches thick. Waste wood that would normally decompose, be chipped up into sawdust, or somehow catch on fire, stuff that would not be used. They incorporate it and sequester that carbon in these in their sales offices there in Hundager. So we looked at CLT. We were looking at our machinery and how we were helping to sell these machines across the North America. We became the rep for Hundager in North America in the early 90s or late 90s to early 2000s. And this started catching on our attention over in Europe in about 2004, like I said, when we went to Mr. Hundager's home. We came back here, started really thinking about CLT, and noticed even in our own backyard the pine beetle problem that we were having. And again, we knew that they were using what most would be considered a waste wood over in Europe, and if beetle kill isn't a byproduct of unfortunate circumstances and becoming almost just a waste sitting up there, we didn't know what else was. So we started looking at beetle kill wood and CLT, and started working with the University of Utah from their architectural department. We were working with the engineering department at BYU and the forestry college there at the University of Idaho, and then obviously with our Forest Service. And we developed a new system. You can kind of see how we dovetail. Joinery and wood is extremely important to us. The CLT was important to us, and we were trying to figure out a way to do something naturally without nails, without glue, and doing our joinery with beetle kill. Again, you can see that blue stain that Jerry talked about. I think there was a question earlier if blue stain was harmful to humans, and it is not. It only just discolors the wood. That's all it does. Correct, Darren?
Yes, that is correct.
Okay. So we put in some air gaps there again for the thermal mass. We lock everything together with joinery, and instead of using glues or screws or nails, we use our joinery. There was a test at the a very similar type of a product that uses, it's more of a joinery and dowel connection, but there was a test in the University of Austria in Graz that was just fascinating to me, and to this day I still like to talk about it. But basically what they did was they took a large warehouse and got that thing down to 14 degrees Fahrenheit, and they built 3 structures, 3 cubes. One was conventional stick frame, about 2 by 6, with man-made fiberglass type of insulation. The other was the insulated concrete block cubic room. I think they were, I want to say they were like 15 by 15 square. And they did one out of this solid wood, about 13 inches thick of solid wood all the way around. They conditioned or got each one of those spaces up to 70 degrees and then cut the power and timed how long it would take and measured how many hours it would take to get from 70 degrees down to freezing. Again, the whole warehouse was 14 on the outside of each one of these cubes. And it's just impressive to me once those walls were warmed and how long it took that coal to penetrate through a massive CLT panel is pretty impressive. This is, let me go backwards here. So this is a product, part of the no glue and dowel lam. We do the cross or the ICLT wall system, and we have a dowel lam roof system, which can be used independently we've used it in concrete structures and steel structures without our wall system, kind of as a hybrid. This describes what is known as Brettstapel over in Europe, or the dowel lam system that's very few people are using over here, but we've incorporated some machinery and some technology to building these floor and wall systems. So they're drilling and doweling at the same time. And then all those dowels line up when you put them on a roof structure or a floor structure in a conventional building. And they kind of like a pencil sharpener so they can line up on site. And that's, again, cutting them into shapes and sizes on the Hundig or PBA. Just another use of technology, CAD, CAM, and that type of stuff that is helping us push us forward. So I'm just going to show you some quickly. This is a timber frame / ICLT structure we built in central Utah. This is a picture of that same shot that Darren was using earlier on the Girl Scout cabins. That's an exterior shot, steel clad, no insulation, just a rain screen and windows and ventilation. And the girls love them. The Girl Scouts wants to do more, and it was a huge success. Another shot of those Girl Scout cabins with the solid steel rain screen on the outside.
Thanks.
This is a home we did up in Wolf Creek, real close to some of those pictures that Darren was showing of some beetle-kill that is up in above Heber. We actually harvested trees from this site and put them into the wall system and roof system. So the trees were actually conceived not 20 yards from where their resting place, which is inside this structure, is being utilized now as a home and sequestering that carbon.
Steve, this is Darren.
Outside the house. Inside, this is the kids' room. They've got a little bunk area.
Hey, Steve, can you hear me?
CLT panels, ICLT panels up in the wall, also in the roof structure, and then our timber framing. This is the den office where we actually use beetle-killed logs along with planed and milled logs to create some of the details and the effects of this building.
Excuse me, Steve, can you hear me?
Yeah.
I think we need to wrap up. We're running out of time for method.
Okay, that's
Thank
it.
you.
Awesome. Thanks, Steve.
Okay.
So Steve, you just have to stop sharing your screen, and then Van can start sharing his screen. And let me just add one thing, Steve, if you want to click on the Q&A, you can see some questions that have come up, and feel free to answer those by text. And then everybody will be able to see your answers. So
Okay.
I think people have been asking some really important questions, and I want to make sure the method has enough time. Thank you.
Am I on?
Yep, you're on. And if you want to drag that participants panel to the right. Oh, I'm sorry. That's my screen. You're good. Sorry, my bad.
Okay, so am I free to start then?
Go for it.
Okay, hi, my name is Van Lewis. I work for Method Studio in Salt Lake City. And we're a Utah architecture firm, and we are committed to quality and innovative design and to our community here. And because of that, we're really excited to be working with the Botanical Center at USU and with Steve and his crew up at Euclid Timber Frames, and it's been a very exciting project. We are big believers in progressive design, and we see a huge opportunity in using this material. I would like to quickly recap a couple of things, but I won't spend much time on what's already been said. We are using beetle-killed timber, and there is, as has already been shown, this is a very abundant resource all over the West, and we, by taking it off the mountainsides and turning it into buildings, we are, I believe, involved in a very creative solution to a pressing problem in this region. We're located between the Wasatch Mountains and the Great Salt Lake, just north of Salt Lake City, and the Botanical Center, as Jerry mentioned, is in Kaysville, and this building that we have designed using ICLTs is on the USU Botanical Center property, and this building's going to be a integral part of the Botanical Center. There are a few buildings up there already, and it's become an important demonstration place and education place for our area, for the Wasatch Front, and we're very pleased to be involved in that project.
Hey, Van, I just want to let you know we can't see your screen yet, so I don't know if you've started your PowerPoint, but I just want to make sure you know.
We have indeed.
Okay, so you need to, all I see is your face, which is lovely, but you need to say share screen, and that should be at the bottom. There you go. Now we got it.
Okay, so what you missed was just a little bit of a zoom in on the region here. We're backing through it right now. But we're zoomed in now on the Botanical Center property where this building goes.
Perfect, thank you.
To avoid some redundancy with what's already been said, I'd like to skip straight to a fly around of the model. While working with the Botanical Center and with Steve at Euclid, we came up with this SketchUp model that shows the building. And I will walk you through it. The building has a large gathering space that will be used for educational and sort of community outreach educational programs. In this view, you're seeing it with banquet seating. On the lower right-hand corner of the building, there's a demonstration kitchen. I think you can see our cursor when we do that. And in the next view,
your slide's not advancing, Van.
You have to click them.
All I'm seeing, I'm on slide 12 of 31.
You can't see the fly around?
Not yet. I'm seeing slide 12 of 31. I don't know.
All right. Well, I thought that everyone could see what's on our screen, and we have the fly around going.
Okay, shoot. We can see your slide 12, but I'm not sure.
Maybe let's minimize this and.
Yeah, maybe if you minimize that, the Adobe, the webinars there. Oh, okay. I see your cursor now.
Okay. My apologies. I thought that was visible to everyone.
Unfortunately, our share screen button seems to have
Oh,
vanished.
if you scroll, yep, okay. I just saw you go to a second slide. So if you go down to the bottom of your screen, there's a green share screen.
We're unfortunately not seeing that, Megan.
Well, you're sharing your screen now, so you've already shared, I think. Have you got multiple monitors on?
It appears that the fly around is not playing.
Yeah.
And so I guess everyone was seeing our slides while we were showing the fly around. Maybe what we need to do in the interest of time, since we only have 8 minutes left and I planned for 15, is we will move on to move through the slides, and we'll see if we can get the fly around posted.
Good idea.
Okay, I apologize for that. So I want to get back to pretty much where Steve left off in his section of the presentation. ICLTs are one particular kind of CLT. I think this answers a question that came up earlier. ICLTs are interlocking cross-laminated timbers. They have no glue and no nails in them. It's a really ingenious design. And as the architects on the project, we've been taking this as a great challenge. CLTs are listed in the International Building Code, and they have established engineering values, but ICLTs do not. And so if we hope to get a building permit for this building, we need to show the code officials that it will stand up in an earthquake and under high winds, that it's safe, that it has, that this is a building material that can make a solid, long-lasting building. In this slides that we're going through right now, you can see some of our construction drawings. I think maybe the best thing to do is just go back to the camera, since I think the slides are thoroughly out of sync at this point.
So, Ben, if you want to stop sharing, it's the stop share button is going to be up top now. Your toolbars.
Yeah. Okay. Well, I thought we had this all worked out, but it appears that we're just unable to sync the slideshow with what I'm talking about. So, can you see camera view now?
Yes.
Okay. So we have basically what we're doing, to borrow a phrase from Steve Shrader, is we're using the belt and suspenders approach to designing with this material. CLTs have been through some preliminary testing in universities, but we have not been through the rigorous, thorough testing that is required to get this material listed in the building code. And so what we're doing is building this building out of ICLTs and then strapping it together with steel and tying it to the foundation with steel so that it can withstand earthquakes and high winds. We also, even though ICLTs are probably quite good insulators on their own, probably a 10-inch thick ICLT panel should have about a R14 value, but that also has not been tested and documented. So part of our belt and suspenders approach to designing with this material is to add exterior insulation to the walls. We also do not have testing data on fire propagation through the material, but we think that it's reasonable to assume that these massive panels behave roughly the same way that solid timber does, which means that ICLT panels should be very resistant to the spread of fire. There are many challenges and opportunities involved in using ICLT panels, and basically the approach we're taking is to add supplemental materials that have known engineering values to the ICLT panels so that we can get a building permit. As Steve has shown, this building does have some documented history, and we are learning as we go and referring to some of the university research that's been done at the University of Utah Architecture Department and at BYU and the engineering school. We're working with a structural engineer who wrote his master's thesis on the performance of ICLT in certain load situations that look a lot like earthquakes. The bottom line here is that ICLTs are, I think, a material with a great future, with great benefits. This material is manufactured locally out of a local waste product, and so there's huge economic benefit to the local economy in using it. It sequesters lots of carbon. This building should sequester enough carbon to be the equivalent of taking 360 cars a year off the road, which is a big deal on the Wasatch Front where we have some air quality issues. And one of the big benefits that I'd like to underline in wrapping this up is that this is also a very beautiful material. First time I went up to the shop, up to Euclid Timber Frames in Heber City, it struck me that this is really a part of our forest here, and it's visually beautiful. It smells like the mountains in Utah, and so having a product that's so congruent with the values of the Botanical Center, with our values as designers, and that is also just really beautiful as an exposed finished material inside these buildings, it's just a great, exciting privilege for us to be involved in that. Again, my apologies for the video.
I have a solution to that. I have it already queued up, so why don't I share my screen and just let you sort of navigate us through it. Does that sound okay?
Okay, I have 1:30 on my computer. Are we just keep going?
Yeah, we'll keep going. I mean, if people need to check out, that's fine. I'm not going to lose sleep over it. This is a really important video, and I think people will want to see it. So
yeah, it was a pretty visual presentation.
Yeah.
Okay, great. Thanks, Megan.
So here it is. I'm going to let you talk us through it because I'm not the expert. You are.
Okay.
Can you see it?
Yep.
Okay. And if you want me to pause it, you tell me.
I will. So we're just zooming down on the Botanical Center lot. This is a compact building, a little over 4,000 square feet. You can see here that there's a large gathering space. In this view, it's shown with banquet seating. Here you can see how that large banquet space, or it could also be a lecture hall, opens up onto the demonstration gardens that Jerry Goodspeed described. The building is designed to have a steel rain screen. Maybe if you could pause it here, right there for a moment. Thanks, Megan. There's a Corten steel rain screen and some native stone on the walls to help this building match the Botanical Center campus. And then if you want to keep playing again, Megan, you can see that all sides of the building open up onto the demonstration garden. And
look at those garage doors. I mean, I just need to point out how cool that is.
Yeah. We've done further development on this, and there's now a beautiful patio on this side of the building. As you go through the front doors, one of the first things that guests will see is a demonstration on CLT construction that you saw there on the left, and a display on beetle-killed timber, which it was partly what I was going to be showing today. Maybe you could pause it here for a second, Megan. So in this view, we're looking at seating arranged for banquet. Can hold about 100 people in this room. Can also be set up in lecture format. Looking straight ahead, you're seeing two barn doors that in this view are screening the demonstration kitchen, but there's an open demonstration kitchen where people can learn about food preservation. They can take cooking classes, and the entire room on a video system can watch those classes take place. I don't know if Jerry sees it this way, but with those garage doors, I was picturing that this would be a great spot for a farmer's market. People could bring in their produce maybe, or maybe a large group could go through the entire process of growing and then harvesting and processing food from the demonstration garden.
That's exactly how Jerry sees it.
All right. So there's educational. The educational mission is of course central to this building. If we pause it here for a moment, you can see the exposed wood. For a moment, you could see the exposed wood on the walls. That's okay, Megan. You can just let it roll. I think I'll try to keep up. There you can see some of the exposed wood on the walls. The ICLTs are exposed entirely on the inside. We've been able to make a very reasonable argument that ICLTs behave very much like solid timbers in case of a fire. So fire would spread very slowly through this building compared to how it would spread through a stick-framed building. There you got a glimpse for a second of the demonstration kitchen. There you go. Room for a large group of people to be involved in cooking displays. These barn doors that you're seeing would be rolled out of the way so that the demonstration kitchen is entirely open to this space, the main gathering space. And now we're zooming back outside. One of my slides shows some landscape design for this area. What you're seeing is a Google Earth image in the background. So that was a little bit in the earlier stages of development.
Great.
Okay, I know we're a little bit over.
All right, no big deal. Thank you so much. Okay, everybody. If you wouldn't mind staying tuned, Mark is going to launch a poll for all of our attendees today. And I would appreciate it if you took a minute to fill that information out. That really helps us sort of plan for future webinars and understand what we're doing well and what we need to improve on. Again, I'd like to extend a warm thank you to Van and Mark and Steve and Jerry and Darren for agreeing to present their information to us today. So again, please take a minute to take those the couple poll questions, and you will receive an email from me that will have a link to this recording. There will be a link to this recording probably in the next day or so. So again, thanks a lot. Thanks everybody, and have a wonderful day.
Thank you.
Thanks everybody. Bye-bye.
Bye.